Hey everyone, it's Mr. Anderson here, and today we're going to begin talking about patterns that aren't modeled using linear functions. We're going to start by examining a problem surrounding or that comes from a piece of American literature that maybe you've read or maybe you've even seen the movie that really sets us up for a very good representation to use a model that's nonlinear. And we've seen the representation web, and we're not necessarily going to talk a ton about the equation today, but we will talk about the table, we'll talk about a pictograph, and we'll talk for sure about the situation. We are going to be starting chapter 5. We're in section 5.1.1 in our CPM ebook, and here's kind of our guiding question. What does the growth of this pattern look like? And I already kind of gave you a pretty strong hint. It is nonlinear. But what does that look like, and what does that mean to us, and how can we recognize that? So the problem that we're going to be starting with, like I said, comes from Mice and Men. It's from an American author named John Steinbeck. And in the setting of the book, there's two guys named Lenny and George, and they are raising rabbits, okay? And suppose Lenny and George started with 2 rabbits, and each subsequent month or each following month, those 2 rabbits have 2 baby rabbits. And suppose that every month thereafter, each pair of rabbits has 2 babies. Now, we got to suspend some disbelief here. Whatever you know about biology and whatever you know about genetics, we kind of got to throw some of those things to the to the wind, because obviously there could be some definite complications with this kind of a model, right? What if I don't have equal numbers of genders, and what about some complications that occur from genetics? We're going to assume that we always have a male and a female rabbit, and we're always going to assume that we have rabbits that are capable of reproduction. So just go with me on that. Like I said, a little suspension of disbelief here. We have 2 rabbits, and those after 1 month, those rabbits are capable of reproduction. Okay, so we're going to determine how many rabbits that these 2 friends have after a full calendar year, 12 full months, and we're going to represent all of these using a diagram, a table, and a description. And we're going to talk about the benefits of each. We're going to talk about why one might be better than the other, and we're going to talk about, a preferred method moving forward. But what strategies are going to help us keep track of the total number of rabbits? I got some good ones for you today. And then what patterns can we use to see that rabbit population growth? And then can we make a prediction about the number of rabbits that we're going to have maybe in the long run? And those are all things that we're going to keep in mind long term. So here we go. I've got this set up in my notes. This is going to be the first part of this lesson, and what you see here is what you saw taken from the textbook. And I already kind of penned a description for us, and hopefully you got this. Hopefully you got this from my language and my description earlier. But here we go. Lenny and George start with 2 rabbits, and then after 1 month, those rabbits produce 2 more rabbits for a total of 4 rabbits. And then the next month, each pair of rabbits produces another pair for a total of 4 pairs, or 8 total rabbits. And this pattern continues for 1 full year, or 12 months. And you can already see that, and then I kind of stopped there. You can already see that this kind of description becomes a little cumbersome, both for me to write and keep track of, but also for the reader who might have to read this. So consider how well you're communicating using this kind of a situation. The same level of difficulty you might have while reading is maybe the same level of difficulty that the writer has, right? Reading this, it's tough to extract the information out. So is the situation the best way to describe this? I don't think so, okay? But I've got in the middle of my table here, I've got kind of a pictograph that I'm going to start to create. And we start with 2 rabbits. And the 2 rabbits are just all by themselves at the start of this problem. So George and Lenny got 2 rabbits, but then a month goes by. And obviously those 2 rabbits produce another pair, and I'm just going to go with a couple R's. But we also have those rabbits existing themselves. Okay, So after 1 month, this is going to be our start. And 1 month later, well, now we have 2 pairs or 4 total rabbits. All right, well, okay. As another month goes by, this pair of rabbits exists itself, but it also produces another pair. This pair of rabbits exists itself, and it also produces another pair. Okay, so now in my second month, I've got a total of 1, 2, 3, 4 pairs of rabbits, or I've got 8 total pairs of rabbits. Okay. I'm not 8, I'm sorry, not 8 pairs, 8 total rabbits. So I've got 4 pairs, I've got 8 rabbits. Okay, I'm going to keep going here. I'm going to move down to like my third month. Okay. Let me see here. This pair of rabbits, they each have themselves, right? Because they continue to live, right? That's the other part that might be a little bit unrealistic, is that, did these rabbits ever get sick and die, right? I don't know how long a rabbit lives. Maybe you're having those kinds of questions. But then each pair of rabbits also produces another pair, and now you might be starting to identify some of the difficulty or issues with this kind of a modeling process. Okay, so let's see, 1, 2, 3, 4, 5, 6, 7. There's 8 pairs of rabbits or 16 total rabbits. And if I was trying to continue this for a 4th month, you can see real quick that I would have some difficulties. So with a pictograph diagram, it's not really any better for me than the description in the long run, but it does help me see the pattern. Okay. I start with, and I'll use a different color, I start with 1 pair of rabbits, or 2 rabbits total. Maybe I want to represent it like that. And then, right here, I start with, after 1 month, I go from 2 pairs to 4 total rabbits. Or one pair, 2 rabbits total to 4. Okay, and then right here, I go to 8. And we're pretty good at pattern recognition. I make it to 16 after 3 months. We're pretty good at pattern recognition, and if I can see that, that's really going to help me with the table that might help me answer that question about John and Lenny, and may help me see that growth pattern that we agree is nonlinear. So let me take these and throw them into my table. Start with 2. After 1 month, we go from 2 to 4. Go to, let's see, 2 months, I go from 4 to 8, and then I went to 16. Now, I asked myself here, what's happening, okay? I've got my table. On the left-hand side of my table, I got the number of months. On the right-hand side of my table, I got the number of rabbits. And here's what I'm thinking already, okay? I recognize that to go from 2 to 4, well, I could add 2, right? This is what we've done already. We've done this work already in this course. And then I recognize that to go from 4 to 8, am I adding 2 there? And you're probably looking at your computer screen and shaking your head. No, you're not, because I know that 4 plus 2 is 6, but I have 8, and I definitely know that 8 plus 2 more is not 16. So what the heck is going on? I can't represent this using some of our familiar techniques as an addition of 2, but what you can do, and you probably see, is I can represent this as a multiplication by 2. I got dot multiplication there, but I can represent this also as a multiplication by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I've got a doubling that's happening, and this is going to set us up for this new kind of pattern we're learning about in all of Chapter 5, but specifically we're going to start to introduce it here in Section 5.1. So I'm going to go ahead and I'm going to complete my table, because remember, my long-term goal here is to figure out how many rabbits that George and Lenny have at after a calendar year, after 12 months. So we want to answer that, and then we're going to re-investigate all 3 of these things and see which one is the best for answering this kind of question. So here I go. I know that if I continue to double by 2, and the other thing is maybe you want to have your handy dandy cell phone calculator here, but if I continue to double 16 times 2, 36. 32, sorry. Then times 2, 64. Then times 2 is 128. Then 256. 5, 12, 10, 24, 2,048, 4,096, and then this becomes 80, sorry, I can't do this one in my head, 8192, I believe. Let me just verify that that last one's true. And again, just got to go ahead here. 4,096 times 2. Holy cow, I was right. 8192 there. So how many rabbits would George and Lenny have after a year? They'd have 8,192. All of these things have their place. All of these answer options that I have here have their place. The description is really, really good when I'm trying to communicate a very short-term description of the problem to someone else. It works really, really well for that. Okay? The diagram is really, really good when I'm going for pattern recognition. If I didn't know that these guys were doubling, or these rabbits were doubling, drawing it out in the diagram helped me. And then, of course, the table had its place, because the table is, number one, it's really going to help me see that pattern, as we're going to see tomorrow or in the next lesson. But number two, it allows me to answer that question. How many rabbits are present after a year? Okay? All of these things are going to have their place. The table I'll share with you for a little bit of forecasting. The table is also going to be a very, very helpful element for graphing. All right? Ladies and gents, a little bit of review preview today. It's just a couple questions. It's 5-6 to 5-10. All right, go ahead and give all these things a try, because as you're trying these items and you have questions, it's really going to draw out what those questions are, so you know what it is you're struggling with, but also so you know what kind of questions you need to ask to make sure you get the help that you need. All right, folks, thanks for watching. Have a great day.